Had a customer call me. He's got an old Electrohome console. This would be from, let's say, early to mid 1940s, maybe just a little after the war. This one here, he said it just hummed, so it doesn't know the words. Too big to bring into the shop. I went up to the customer's place, pulled the chassis out. We're gonna get this thing working. This is a two-piece unit. It's got a separate amplifier and a separate radio tuner. Let's check it out. Here I have an old Electrohome. This is part of a console system. Pulled the chassis to service it. So first things first, I had to remove the actual radio chassis. This was a two-piece unit, so it had an amplifier that was on a separate chassis mounted in the base of the console cabinet, and then of course I had a record player on one side and then the radio on the other. So this is the radio portion, and I'm going to remove the chassis so I can put the cabinet away for safekeeping while the chassis is worked on, and then we'll work on the amplifier and the radio. It's going to require a recap for sure, because apparently it just doesn't know the words. All it does is hum. We'll start by removing the knobs. Because it's still got the plastic around the knobs themselves. These knobs I don't think have ever been removed from this unit. Oh, they're held in place with a screw. Well, that would explain why they don't just pull off. There's a screw that needs to be loosened for them all. Now I would date this probably mid 40s. Look at this. Look at the knobs. Like they're wood. These have all been turned. Someone did this. Each one of these was turned by hand. Beautiful. Beautiful. You don't see workmanship like this. And they've still got the felt and the plastic protectors to prevent the cabinet from being scratched. This was put on, believe it or not, to prevent the cabinet getting scratched by women with like either fake or long fingernails, so that their fingernails wouldn't scratch the wood. That's the reason that these were on, and they came this way from the factory. Just going to put the knobs away so that they're safe, and then we'll get around to removing the chassis. This big screw here holds the chassis in place on this one. That's like a number 3. Oh, the whole base comes out good. I didn't know whether the base itself was attached at the bottom. That's why I took the screws out of the back, but they got to come out anyway. But a couple more on the front. Anyway, now the chassis is out, I can put the cabinet away so that it doesn't get damaged, because this one is in absolutely immaculate condition, as you can see. Not as much as a single scratch on it. We want to keep it that way. Looks like someone left out a couple of the screws when it was serviced before. Okay, the bottom lifts off. Look at all those capacitors that are going to need to be changed. This is just the radio portion. So I got to change all these paper caps. I do an inventory, make sure I've got what I need, and if not, run down and pick some up. Here's the companion amplifier. It's going to have a big 3-part cap up here. A couple 40 microfarad and 20 microfarad at 350 volts. I'm sure I can, and a 20 at 150. We'll replace this. I'll leave the filter in place. I'll just replace the caps on the bottom, put some new ones in on the bottom of the unit itself, and a couple of bypass caps, 0.2s, 0.5s, 0.05s, so 047s, 0.2s. I'm not going to have all these in stock because I've done a few restorations over the past couple of months and I've used a lot of them up. Looks like someone's changed the power cord on this in the past, which it has been. and how this is wired. Power comes in, there's a convenience outlet here for the record player, and it goes to a plug. There's a plug that plugs into, there's two plugs that plug into the other radio unit. One plug for power, and the other plug is for the audio and high voltages. Power is switched. Applies power to the transformer. Transformer goes to the rectifier tube here. Rectifier tube rectified by the main filter, choke coil here, and then high voltage is then fed back up to power the tubes on the other board. This is the audio output transformer. So on here we've just got the rectifier tube, preamp tube, and I think it's probably push-pull audio on this one. Yeah, this is a push-pull audio output, so two output tubes. This is a preamp tube. And that's all that's on this one. So I'm going to take inventory, see what I need as far as capacitors go get the stock that I need, and then we will continue and get this one rebuilt. So I went and picked up a bunch of parts. I had to hit two different places because I couldn't get one value. And I had two different shops. There's apparently a shortage of capacitors, believe it or not. So let's get started. I'll start with the radio side. We'll change out all these ones first, and then I'll do the amplifier side. We'll test everything out, make sure everything's working. I couldn't get light bulbs. I hope they work because they didn't have, neither shop had these type of bulbs, 6.3 volts. So hopefully the bulbs are okay. Looks like they're probably burned, but oh well. I had to do without light bulbs. Not the end of the world if the bulbs don't work. Anyway, let's get started. We'll start on this side. We'll start over here with this little cap over here. Swap this one out first, and make our way through the rest of the radio and get them all changed out. So the first one to come out is one that's leaking all over the place. It's a wax cap that's leaking, and it's connected to a resistor. This one. Made in, British made. Yikes, 750 working volts. Well, I don't think I'm going to have one like that. I think I got 600s. But this is a 0.002, so we'll start with this little cap. Okay, the next one's a 0.01. I know I got some of those. As they say, some of them were getting hard to get, a few values, but I was able to get most of the ones that I needed. The excuse that they had at the store was that shipments are so far behind now due to the component shortage. I knew there was a semiconductor component shortage. I didn't realize there was a capacitor component shortage. This one looks like it's been changed out before. This is a replacement that's in here, this one. It should probably be changed out again just because it's old. But it's not one of the wax ones that it gives us all the trouble that the wax ones do. But it's still going to be a cap that probably would benefit from being replaced. It's a coupling capacitor in the audio circuit, coming right off of the wiper for the volume control. If we look at the old one that just came out here, we'll measure the microfarads on this. It's gone up to a 0.03, 0.033, 0.034. It's a 0.01, and here's the new one. So it hasn't failed, but it's likely starting to become electrically leaky internally. Again, the old ones though didn't have that great a tolerance, but physically, as you can see, the new cap of the same value is much smaller than the old ones. And this is one of the reasons why the outside foil, even though I've measured them, I check it on the scope. Whenever I get new caps, I put them on the scope and just look at them and mark them accordingly. Most of them, the outside foil is the left side. A lot of these small ones, it's very difficult to distinguish which one is which because the physical size of the capacitor is so much smaller than these old ones that the outside foil is not really a big a factor just because of the physical size of the part. The exposed foil portion is much smaller on a physically smaller capacitor than it is on one of these big ones. So I don't emphasize as much on checking them and verifying them as, say, a certain other person does that does a lot of retro stuff. Just because it's not a big an issue, unless you're using capacitors that are a large physical size. Then you can actually see the difference. On these smaller ones like this, when you're looking at the scope, you're looking at microvolts difference in the amount of noise. Put an old cap on and yes, you can see a huge difference when you turn the outside foil around. When you put your test lead on the outside foil as opposed to on the inside foil, you'll pick up a lot more just superior radiation from radio transmitters, lights, electrical noise. You'll see it on the scope. When the ground is connected to the inside foil and your probe is connected to the outside foil, you'll see a much larger noise floor than when you connect it the other way around, when you've got the ground going to the outside foil. On larger physical capacitors like these ones. But on these smaller ones, there is a difference. You can see it, but it's much, much smaller. And therefore not going to cause as big an issue when you put in a cap, if you put it in with the outside foil going to your signal side as opposed to the ground. You're really not going to notice much difference in the operation. And that's one of the reasons I don't harp on it like, say, some other people do, because it's not as big a deal as it was with the older parts.
And that's probably why the manufacturers don't even bother to mark which side is the outside foil.
I know someone's going to disagree with that because opinions are like assholes. Everybody has one. But I can show you on the scope. I can show you the difference between the two of them. I've done it before in other videos. And on these small caps that have the small form factor, there is just nowhere near the same difference between one side and the other. I think it's absolutely ridiculous that the city of Vancouver has a plastic bag ban. So you can't get anything in a plastic bag these days. And the store, if you want stuff in a bag, they put it in a paper bag and charge you 25 cents for a paper bag. Yet every single little part comes in a plastic bag. These are exempt. But a plastic bag to put everything in when you're done shopping, well, that's not allowed. And if you want it on paper, you've got to pay 25 cents. Same as in Vancouver. You go to the drive-thru and want to get yourself a cold beverage to drink on the way home, they charge you an extra 25 cents for the cup. But only in the city of Vancouver. Outside of Vancouver, you don't pay it. Now, these next ones are 0.05. I've got 0.047s, but the 0.047s I've got are much smaller. There's another 0.1 down here. I wonder if it might be beneficial to change it first. No, we'll do the 0.47s. The 0.47s I had to get were these ones here. 0.047. And they have much shorter leads on them. So I'm going to cut these leads short right off the cap itself to try to get as much lead as I can, just to get these other ones in place. They're going to be a tight fit, but electrically they're the same, so don't anticipate any problems. It's just they're physically a different size. It's just the leads themselves are going to be a little bit shorter. I spent a whole bunch of time looking for the stupid cap that I dropped, and it dropped into my shoe. Like, where is it? Where the heck did the thing go? I'm looking and looking and looking, and I look down, and it's like, oh, it's stuck in the tongue of my shoe. And of course, this is one of the ones that I've only got. I need 10, and I picked up 10, so I don't have any spares. So if I lose one of these ones, I'll be making another trip to buy some more. And I already drove enough today to buy these ones. I don't have to go and get any more. Now, it's worth mentioning, if I haven't mentioned it already, which I don't think I did in this video, but the reason we're going to the trouble of changing out all of these wax paper capacitors is because what happens to them is the paper, the acid in the paper, when they were manufactured like 80 years ago, makes the paper become conductive and turns the capacitor into a resistor. And many of these are used as coupling capacitors where they're blocking DC from one stage to the next. Some of them are going to be bypass capacitors, which are just connected to ground. But even that can cause problems when they start to go leaky, because they can overload the power supply and burn out the power supply. So we changed them all out, every last one of them, because if they haven't failed yet, they will. Paper capacitors were notorious for becoming electrically leaky. And it would be in the megaohm range. But when you're dealing with the voltages that are being dealt with in vacuum tube equipment, it's microvolts that might leak across the capacitor plates, or between the capacitor plates. Microvolts, but microvolts can take a tube that's biased off and bias it on. You'll end up with DC voltage on the plate changing and drawing excessive amounts of current, which can burn out tubes, and it can also burn out transformers and coils and stuff. So just as a precaution, anytime you run into an old tube radio like this, do yourself a favor and change out all the paper caps, every last one. You don't even try checking them. You just change them, because they're going to be shot. Guaranteed, they're going to be shot. And if you want the radio to have any kind of reliability and last another 70, 80 years, you do yourself a favor and just change them all out. On equipment from the 70s and 80s, I generally don't change every capacitor in electrolytics unless they're bad. Just because I've had from experience, I shouldn't say a lot of people, but I had one fella that brought me a receiver and wanted all the caps changed. I think it was the Sansui actually, and he bought a repair kit online. Paid about $150 for this repair kit, but didn't feel comfortable putting it in himself, so he had me change out all the caps, and he wanted to keep the old ones. Normally I would just throw them in the garbage, but he wanted the old capacitors, so I said, okay, no problem, I'll keep you the caps and you can have them. And anyway, he gets it home, and I listen to it, and it sounds fine. Like, to my ears, yeah, it sounds fine. He gets it home, and he calls me up, and he goes, something's not right. You didn't do something right. What do you mean? Well, it just doesn't sound right. What do you mean it doesn't sound right? It sounds fine. I listened to it. Ran it for a while. No, doesn't sound right. You something wrong with it. So bring it back, and I plug it in, I turn it on my speakers. Sounds fine to me. He goes, well, it doesn't sound like that on my speakers. It just sounds terrible. It just doesn't sound right. So I explained to him, so well, it's probably the capacitors you put in. They're a different chemical makeup. This is not acceptable. It was working fine before I changed them. Let's go back to the other one. So he brought me all the caps back, and he paid me to put all the old capacitors back in. Now, it wasn't one that had a problem. It wasn't one that had a failure. He just wanted to change the caps because he had read that you got to change out all the caps on a mid-70s. It was a mid-70s Sansui. Anyway, I went and put all the original capacitors back in. He takes it home and he goes, now it sounds proper. And he paid me again to do it, to put them all back in. So that was my one experience recapping an entire unit that went south, and the customer just was not happy. It sounded fine to me, but to his ears, he had become so accustomed to listening to how the old, probably very spongy, very soft sounding caps sounded. Wasn't as, the newer ones were more bright than the original ones, and it was a sound that he wasn't used to and didn't enjoy. So I generally, on more modern solid state stuff, I don't go out and say to someone, let's change every single cap in this unit, because there's one bad experience where I had to do the job over again because somebody wasn't happy with the new sound. This is going to be a fun one to get to. It's buried way down inside here. Just to get in to hook this wire up is going to be fun. I might be further ahead just to take that resistor off as well, just so I have a little more room to work in here. Okay, what is this one? It's a 0.05, so that's a 0.047. This is going to be one I'm just going to have to tack it on. I won't have room to put a hook on this one, I don't think. Maybe I will. It's going to be a fun one to get in here, that's for sure. Alright, it's a little better. got one more to swap out in the radio preamp circuit, another 0.47. This will be the last one of this one. And then the next ones will be the amplifier. We'll get onto that one and get this thing running. Hopefully, say the guy plugged it in and tried it out. I'm hoping he didn't do any damage to it, because I always tell people when you pick up something like this, don't plug it in. Don't plug it. Oh, there's 2 more in here. Don't plug it in until you've done the required work, because you could damage things. So hopefully there's no damage done to this unit. One more here on this coil. Let's remove these other resistors. They probably just unsolder here, or these wires. Should be able to just pull these out. You can hear the radio going in the background. The news is on. I guess that gangster thought he was safe taking a cab, and one of his rivals shot him in the cab and shot the cabbie too. Be a fun one to get this one done, that's for sure. Impossible to get at. I mean, it's like, I'm sure this one was probably soldered on before they put this coil into this awkward position. But it has to be changed. Well, I got that one soldered in there. It was not so simple. It was a real pain to get this one in. I was using pliers and I couldn't see it on camera because my head was in the way. It was just one of these ones that's almost impossible to get at. Of course, I had lots of light in there so I could see what I was doing, because it's dark at the back here of the chassis, comparatively speaking, compared to the rest of the shop. So I'll reconnect those 2 wires that were on here with the cap. twist these two together first before soldering them both together. Make sure everything's connected. Yeah, that's good. That's solid. That's solid. Okay, I think that's got all of them for the radio chassis. So let's move on to the amplifier. Okay, now to the amplifier. This one's got what has this one got in it? 0.5, I think. Although these ones have been changed out. These ones are newer types. These have all been swapped. Same with that one. These have all been changed out. 0.01, 0.05, 0.05, 0.05. But we are going to change them again just because we can. And I have parts. So 0.001 Mallory plastic cap, patent pending, made in the US of A. So it's going to be a bunch of these ones here. Let's see how many I've got. I got 4 of them here, and I got 0.05, 0.05, and 0.0. Is that a 0.05 or 0.02? 0.01, 0.02, and 2.05s, plus the electrolytics. That's what's got to be changed out on this one. You're wondering why they've got this covering on here. It's just to prevent any short circuits if the wires were to get bent. They're not necessary, but they're just an insulator. Yeah, I'm down to the last 2. I had to extend the wires on this one a bit. Just extended the wires, put a couple of extra leads on them just so that they would fit. I got 2 more down here to change. This one here, which has obviously been changed out before, and this other one here, and then the electrolytics. There's a reason why a lot of people like working on this old tube gear is because it's actually pretty simple and there's a lot of room to work. So this is really quite basic electronics. Much easier for people to understand vacuum tube technology than the modern stuff. That's why there's a lot of hobbyists that like working on this old equipment, because it's easy to work on. Now, I should stress, if you're going to work on anything with vacuum tubes, you have to be extremely careful, because the voltages in vacuum tube equipment can be hundreds of volts. Plate voltage on an amplifier like this is probably around 300 volts. And then the last one is this one here. And we'll need to extend the lead on one of these as well. Also on vacuum tube gear, the capacitors can hold that voltage for a long period of time. And that's because when the tubes are cold, there's nothing to drain the energy away. So if you're going to work on something that's recently been plugged in, it's a good idea to short out all the caps before you stick your fingers in. Okay, that's all for the paper caps that have been swapped out. I got the electrolytics to do now. I gotta dig them out. So this is the, it was a 20. I'm putting in a 33 at 160 in place of a 20 because I couldn't get a 22. They were out of stock, if you can believe that. Stores out of stock of but pretty much everything these days. Component shortages. First it's chip shortages, now it's capacitor shortages. Everywhere you turn there's parts that are in short supply. Scoop this around the ground tab and solder it down. Hopefully this iron will generate enough heat to make that solder melt. Should. And that, boys and girls, is the difference between a cheap Chinese soldering iron and a good old Weller. This thing generates enough heat that I can actually solder the components down to the chassis. There we go. We'll put the two negative terminals together. And then this will be connected to the chassis, and the positive terminals connected to the respective terminals on the other cap. Of course, we'll disconnect it from the cap first, obviously, otherwise it's going to have the original cap loaded up and it's probably shorted or open, probably more than likely open, but we don't want to have it connected. So let me get this soldered down to the chassis, and then we'll get the other wires moved over to the other terminals. So this is the second capacitor here. I was connecting the wires together.
Once again, this welder has plenty of heat. I can solder those right down to the chassis, which is something that I wouldn't even try with the old iron, the old Heiko
Grounding
clone.
the cap to the chassis.
This is the best iron that I've ever had, and I was certainly fortunate to get it donated. As I say, I had one before and it burned out and I couldn't get parts for it.
Make sure these other wires are pulled away from the filter so they can't touch, and then the input wire, I can actually take it right off because I can put this one right to the terminal on the tube here, to the plate.
So thankful that one of my viewers donated this iron because it has just been fantastic.
And then this other wire can actually come right off. It will no longer be required. Okay, that pretty much completes the recap. Just gonna double check and make sure there's no shorts on here, and then I go get the radio portion. We'll plug the radio portion in, hook up the speaker, and make sure that everything is functional. Okay, unit's plugged in, dim bulb tester. That's a good sign, no shorts. The dial lights actually light up. Are all the dial lights lighting? 2 of them are lighting. All 3 dial lights are lighting. Excellent. Let's see if we get any sound. There's no antenna connected to this thing. Don't even know if I'm on the correct input. Oh, one more cap on the top here. Just make sure I'm on the correct input. I don't know, because this is the input switch. I don't know which is AM, which is shortwave, and which is, that's obviously AM there. Okay, let's give it full power.
I'm extra at ease.
Here are the tubes warm up now.
I play tennis. The best thing about tennis is no matter how good I'll never be as good at the wall.
Hook up something as an antenna, just a piece of wire.
Wendy's breakfast just got better because we're giving away free small coffee. September 4th all day at participating Wendy's. No purchase necessary, limit 1 per person. Hi, Keith here from Speedy. Between regular heat wave and heat damage, your windshield wipers can be replaced every 6 months. Don't wait to see clearly again.
I think we need to clean the volume control. Let me grab some contact cleaner.
One on your back-to-school shopping list. With Chatter, you can get nationwide prepaid plans with nationwide coverage from only $15 a month. That's really, really affordable. If you're starting school or just need to stay connected, Chatter makes it easy with no credit checks, no term contracts, so it's easy to say yes, yes, yes.
That's just the tone control cap.
Now you make the call.
That one's not critical. I don't need to worry about changing that one. That's just the tone control cap. Even if it were to short, it's not going to hurt anything. It's just going to bypass everything to ground. And normally you're not turning it down anyway. You can hear it works.
Fulham on the Maryhill bypass westbound at Broadway. Westbound is blocked. Southbound Broadway down to 1 lane. And an earlier collision on the Lionsgate Bridge, still seeing delays in both directions.
So this one is done.
I've heard the last weather forecast because they're introducing direct flights from Vancouver to Fiji twice a week starting November 25th. FijiAirways.com to book.
All the lights are working.
10:40 a.m.
And now it's Eddie Murphy.
Okay, I gotta shut it down at that point because I'm sure that probably will pull a content match. But this one's done. This one's fixed. I'm gonna just tweak the IF a bit, maybe just see if it needs to be tweaked ever so slightly. Right on as far as frequency goes, it's 1040, and that's exactly where it is on the band here, showing exactly 1040 right there. So that's good. The lights are lighting up the dial, so the dial will light up. I don't have to worry about that. And I'm just going to just check the IF on here and see how it's sounding, whether it can be peaked up at all. I think it's sounding pretty good. I'm not using an antenna. I just got a piece of wire on here, and it's pulling the local stations in no problem.
Basis negative 0.2%, just the opposite of what the street was looking for. The equity market in the Lion City will be up and running at the top of the hour, and we'll have more on markets in 15 minutes. Let's get global news. Denise Pellegrini is in the Bloomberg newsroom. Denise.
Thank you, Doug. Former President Trump took the fifth today. When questioned by New York's Attorney General about the doings of the Trump Organization, AG Letitia James is looking into asset values related to loans, insurance, and tax breaks at the organization. FBI Director Christopher Wray says he can't talk to FBI agents at Trump's Mar-a-Lago home on Monday. The Justice Department says former President Trump's national security advisor Bolton was the target of a murder-for-hire plot by a member of Iran's Islamic Revolutionary Guard Corps. A newly detected virus emerging in China spreading to humans from shrews. The Langya virus is mostly sickening farmers. Meantime, China is ordering thousands of hospital beds as COVID spreads in Tibet. And China has issued its first white paper on Taiwan since Xi Jinping came to power. The paper blames the island's independent seeking.
That's me firing up the AM transmitter.
Quick take powered by more than 2,700 journalists and analysts in more than 120 countries. In the newsroom, I'm Denise Pellegrini. This is Bloomberg. Brian?
All right, Denise, thank you very much. 10 minutes here before the top of the hour, something that Denise mentioned there, the white paper that China has.
Turned on my little transmitter for testing. Anyway, I think this is done. So there we go. Another one saved. I'll have to take this back and install it. I pulled this out. I went up to the customer's place and pulled the chassis. So I don't have a picture of the entire radio itself to show you. But anyway, it's a nice, beautiful cabinet. So just putting the original felt and plastic protectors on.
There we go. Knobs are back on. It's ready to go back and be installed back into the cabinet. Thanks for watching. We'll catch you in the next one. Bye.